In proof number 37, I'm going to start by marking what this perpendicular given information means. If EF is perpendicular to EG, that means I have a right angle where those two segments meet. And likewise, if HG is perpendicular to EG, I have a right angle where those two meet. I'm then given that EH is congruent to GF, so EH is congruent to GF, and I'm trying to prove that angle H is congruent to angle F. So I like to mark that in a different color so I remember what I'm looking for. Well, the first thing that jumps out at me is if I can show that these two triangles on the left and the right are the same, then I'll be able to mark those two parts, angle F and angle H, very quickly by CP/CTC. And I already have one set of angles the same and one set of sides, so what I'm looking for is more angles or more sides. And the first thing I see is EG is reflexive and it's in both triangles. So I have an angle side-side relationship matching up to an angle side-side, which normally we say doesn't work, but in this case it's a right angle side-side and a right angle side-side, which we call hypotenuse leg. So I can prove that the triangles are congruent, which then I can take the two parts, angle H and angle F. So let's see if we can write that in a clear, understandable proof. I start with my given information. EF is perpendicular to EG. HG is perpendicular to EG. And I was given that EH was congruent to GF. And all of that was given to me. Now you got to be careful when using HL. The first thing I marked was the right angle. Okay, a lot of people put that in there but then forget to say where it came from. Angle FEG and angle HGE are right angles, and I know that because that's what it means to be perpendicular. So I know they're right angles because of the definition of perpendicular. Now if I'm going to use hypotenuse leg, the only type of triangles that have a hypotenuse and a leg are right triangles. So I really need to say that triangle FEG and triangle HGE are right triangles. And a lot of people leave this out because they don't think it's important, but it is. And I know that that's a right triangle because of the definition of right triangle. If I leave that out, then I can't say I have a hypotenuse and a leg because only right triangles have a hypotenuse and a leg. So after I already have my hypotenuses marked, my right angles are there, which gives me the right triangles, I need to mention that I grabbed side EG congruent to itself, EG, because of the reflexive property. And I'm just going to go ahead and double check now before I move on. HE and FG, that was my hypotenuse. EG and EG, that was my leg. So I have mentioned that I have a hypotenuse congruent to a hypotenuse and a leg congruent to a leg, but I also mentioned that I have right triangles. So I am set up now to say that triangle HGE is congruent to triangle FEG because of the hypotenuse leg theorem. And now that I have the triangles congruent, I can grab the two parts that I was interested in the very beginning, angle H congruent to angle F, because the two triangles are congruent, and as we know, the corresponding parts of congruent triangles are congruent, or as we say, CP/CTC.